Good evening, Timmu. So today we are going to discuss about the continuous probability distribution. So which is the same syllabus for COSM and MSF branches. MSF subjects also. Now we can see that in the continuous probability distribution and part one, part two, fundamental sampling distributions. So in the continuous probability distributions, you have a uniform, normal, gamma, and exponential distributions will come. But right now you have that in the syllabus, 20, page 25, you don't have that the gamma and the exponential distribution. You have that the normal distribution, and then I have the basic of the uniform distributions. And sampling distributions, you have that part B, random sampling and sampling distributions of the mean, center limit theorem, T test, F test, and then next Z test. All those things will be there in unit 3, right? Come to the normal distribution. Here you can see that continuous random variable has a infinite number of possible ways that can be represented by an interval on the number line. Now you can see that here I kept that 0 to 24 hours spent studying in a day. So, and then we can see that the time spent studying can be any number between 0 and 24, right? So that's the reason we are going to find out the probability distribution of continuous random variable is called continuous probability distribution. Okay. Now the data will be, we have taken that in the example. The following data represents the heights in inches of a random sample of a 52-year-old children, and we need to create that the relative frequency distribution with the lower class limit of the first class equals to the 31.5 and class width of 1. And then now we can see that we are going to make that the drawing of histogram of the data. So this is the data we have taken, sample data from the data set, and based on that data we are going to making that draw of the histogram heights of the 2-year-old males in inches. Now we are representing, you got that the height and with the percentage like this. This is the histogram. Now in the histogram also we are going to make that where the values will be, you are going to get like this. No, so this is the graph is nothing but the bell shaped graph, and this graph is nothing but the normal distribution graph. Now, properties of the normal distribution. The most importantly, probable distribution in statistics is the normal distribution. And this is the normal curve, which is in the form of the bell-shaped curve. The normal distribution is a continuous probability distribution for a random variable of the x. The graph of a normal distribution is called the normal curve and starts with the minus infinite, ends with the plus infinite. And few more properties of the normal distribution. You can see that the mean, median, mode are equal. The normal curve is bell-shaped or symmetrical about the mean. The total area under the curve is equals to 1. And then next, the normal curve approaches but never touches the x-axis, and it extends that both the sides away from the mean line. And there are see that area you can take that. So left hand side mu minus 0, right hand side mu plus sigma, sorry, not mu minus sigma, and right hand side mu plus sigma. So in the center of the curve we are going to take that, right? In the center of the curve we are going to take that mu equals to 0, and the graph curves are downward. The graph upwards to that the left will be this and right hand side will be there. The points at the curve changes from curving upward to curving downward is called inflection points. One is upward, another one is downward. Now this is the area of the normal distribution graph. That's what we are. So these are all mu minus sigma, mu plus sigma. This is left hand side and this is the right hand side. So like this, no, this side and this side, these two are called the inflection points. So from here to here is nothing but the region of the normal distribution. And the this probability density function y is equals to 1 by sigma root to square root of 2 pi e power minus x minus mu whole square by 2 sigma square. And e always you are going to take the 2.178 and n equals to 3. Sorry, the pi value is 3.14. And now we can see that this is the probability density function. Okay. Next, mean and standard deviations of the normal distribution. So normal distribution can have any mean and any positive standard deviation will be like this. Suppose I have taken mu equals to 3.5, the graph will shows like this, and standard deviation also shows like this. If you take that mu equals to 6, standard deviation will be like this. And these two are the inflection points, and these two are the inflection points, right? Normal distribution, the area of the curve. Okay. So 99.7% within the three standard deviations, and two the standard deviations is 95, and one standard deviation is 68%. Okay. Next, the standard normal distribution. Some more properties, a normal density curve. You know that the symmetrical, this is the zero, mu equals to zero, and the highest point occurs at the z is equals to 0, and it has inflection points, no, from here to here, right? So these two are called -1 and +1. The area under the curve is always 1, and the fifth point, the area under the curve right side equals to 0 and equals to the left hand side, but equal distributions will be there. Left hand side -1/2, right hand side +1/2. As a jet increases without a bound, the graph approaches but never equals to 0. As z increases without a bound, the graph approaches to but never equals to 0. The empirical rule is 68% of the area under the graph is -1 to 1, 95 is -2 to 2, and 99.7% is -3 to 3. So that's what we can observe here in these, right? And then next, properties of the standard normal distribution is the curve area is very close to 0, and we'll get the score will be -3.49. The cumulative area increases as the jet increases, and the cumulative area z is equals to 0, then you are going to get that the 0.5000. The cumulative area is close to 1, and the jet score will be z equals to 3.14. Okay. Normal distribution, finding the probabilities. Just for getting into the clarity, I kept here. So this x is less than, probability of x is less than 50. You make it like this. Suppose the values mu and the sigma values. So what's the approximated? No, mu equals to 10 and sigma equals to 5. And later on, we can see that how you are going to find out using that the probability in normal distribution. Okay. Now the only the properties, no, that's I need to show by using this term. So the same thing, and if mu equals to 0, sigma equals to 1, see, now the z becomes, z is less than 1. Okay, same area, same thing, standard normal distribution. Now we can see that. And the standard area under the curve is 0.8413 by using probability. And normal distribution finding values. So these are all the values. You are going to get that by using the three statistical tables when you want to solve the problems. Nothing to worry, and these are all the jet scores. Next, fundamental sampling distributions. So you know that the population and samples, all those things will come in sampling distributions. Now come to that the population definition. Population consists of the total of the observations which are concerned. The number of observations in the population is defined to the size of the population, and it is denoted by capital M. And the population is said to be finite or infinite depending on the n size. It may be a finite or infinite also we can take. Since it is impractical or uneconomical or time consuming, thus to study that entire population, it's very, very difficult. That's the reason we are considering always that the data set, whatever you are taking, that no finite subset of the population, which is going to call it as a sample. Now, sample is a subset of population. Size of the sample is denoted by n. Sampling is the process of drawing samples from given population. Next, parameters and statistics. These two are the very, very important parameters we had to take for the population. Samples we need to take that the statistics. So thus Statistical measures of a constant obtained from the populations are known as population, and those parameters are the simply parameters. Example: population mean, population variance, standard deviation also. And statistics, similarly, statistical quantities computed from the observations are known as a sample statistics. Briefly, we can call it as statistics. Example: this is population. No, here sample means, sample variance, sample standard deviation. Thus, the parameters refers to the population, which statistics refers to the sample. So we can see that now mu will be in a population sigma p, and the same thing you are going to the x bar and s and then p. So these three are samples and these three are population. And equation will be population mean will be like this, sample mean will be, the difference is this is mu and this is the bar. So these are all the parameters. Even variance also, this is sigma square and this is s square. I kept that, I think you know how to solve the problem, but I kept here. So the population numbers, they have given 2, 3, 4, 5 and 4 numbers, and the size will be the 2. And we need to find out that these two are related to population, these two are related to the sample sum. Population mean, standard deviation. Here, population sampling distribution mean and standard deviation. I kept that one thing is I repeated, don't worry. And you are going to find out that this is the mean of the finding that mean value and a standard deviation of the population value, and you'll get like this. Now going to that the sample stuff. So this is the with the replacement, no, with the replacement. So with the replacement we can take, or without replacements also. Sorry, actually I had to keep that without replacement. I kept that. So okay, without replacement I have taken NCN, and you got that the 6 values. So these are all the 6 samples we got, and from that we are going to find out that mean and standard deviation of the population, and then mean and standard deviation of the samples also. Okay. And this problem already we have seen in the class, and you know that it's very very important also. That's the reason I'm not taking that much more time to explain about this. And going with that, the sampling distributions. Sampling distribution is the probability distribution of a sample statistic that is formed when sample of sizes n are repeatedly taken from a population. So this whole thing is, you can call it as a population, and these are all the samples. Okay. So hope you understood that the normal distribution and the sampling distributions of the uh, thing in this unit 3. Thank you.